This lesson is going to discuss some rational functions. A rational function is a function whose rule can be written as a ratio of two polynomials. The parent rational function is f of x equals 1 divided by x. Its graph is a hyperbola which has two separate branches. Like logarithmic and exponential functions, rational functions may have asymptotes. The function f of x equals 1 over x has a vertical asymptote at x equals 0. It's the green line. And a horizontal asymptote at y equals 0. It's the red line. The rational function f of x equals 1 over x can be transformed by using methods similar to those used to transform other types of functions. So what we're going to be doing in this lesson is looking at rational functions, graphs that look like this, and describing the transformations that happen when different numbers are surrounded by the parent equation, 1 over x. This would be a good slide to make note of and have written down. F of x equals a. Well, typically, and right now, a is going to be 1. We're only going to deal with an a equal to 1. If a was something different than 1, we might have a vertical stretch, or we might have a compression, or potentially a reflection depending on if it changes signs. The two transformations we're going to focus on is a horizontal translation, described for h, and a vertical translation for k. Now, h can be tricky because what we're looking at here is h alone by itself. So when you have x minus a number, we'd say that it's actually the opposite sign. So here's what it looks like when we have a negative h. Well, remember, if we have a negative and a negative, this typically is written as x plus h. So keep in mind, if you see x minus 3 on the bottom, that means h is a positive 3. The minus sign is permanent, so we would interpret that as a positive 3. So using the graph of f of x equals 1 over x as a guide, describe the transformation and graph each function. G of x equals 1 over x minus 3. Looking at our notes, we're given h. H describes a horizontal translation. If it's positive, it'll go to the right. If it's negative, it'll go to the left. We have x minus 3, which is technically, remember, our positive 3. So this would be a translation to the right 3 units. When you go to graph, you can type both these into the calculator and just make a rough sketch. Here's what the graph would look like. Okay, we've got f of x equals 1 over x is in blue. The transformation, if it goes 3 units to the right, it just slides over 3 units, meaning that vertical asymptote slides to the right 3 units. And this is what in the graph in red is our transformed function. Okay, we have 1 over x minus 2, that's on the outside. So this would be a translation down 2 units. Again, you go to your graphing calculator, type this equation, g of x in, type f of x in, and here's what the graph would look like. Not great. Because k is equal to negative 2, it goes down 2 units. Take a look at these examples. G of x equals 1 over x plus 4. That means 4 is negative and it would go to the left 4 units. In part B here we have g of x equals 1 over x plus 1. That means k is 1, so it would go up 1 unit. That's the first idea of transformations. Our second idea for today is using h and k to find the vertical asymptote and the horizontal asymptote. That's all we're required to do is to look at h and k again. The vertical asymptote is the line where x equals h. The horizontal asymptote is the line where y equals k. So in your assignment, and in this problem here, it's going to say identify the asymptotes and the domain and range. We are not going to partake in the domain and range. So when you go to your book assignment, if it asks for the domain and range, you can ignore that part of the question. But we can figure out the vertical asymptote. That is the line x equals h. H in this case is actually -2, so our vertical asymptote is going to be the line x equals -2. Our horizontal asymptote is the line y equals k. K is 4, so it's the line y equals 4. So again, here's this example. The vertical asymptote was the line x equals -2. Pretend my line went over -2 there. The horizontal asymptote is the line y equals 4. So it's a straight line across at y equals to 4. Let's take a look at another example. Let's go vertical asymptote. It's x equals h. H in this case is a +3, so it's x equals 3. Horizontal asymptote is the line y equals k. K is out here, and looks like it's -5. One last example for good measure. Again, ignore the domain and range part of the question. Just identify the asymptote. So vertical asymptote is going to be the line x equals +6. The horizontal asymptote is going to be the line y equals